Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello students, welcome to Maths online class. We are in types of functions. Under that next type of a function is polynomial functions. Okay, so what do you mean by polynomial functions? A function f from R to R defined by f of x is equal to a naught plus a1x plus a2x square plus a3x cube plus etc plus an x power n, that is called a polynomial function. Okay, function which is defined in this way: f of x equal to a naught plus a1x plus a2x square plus a3x cube plus etc plus an x power n, that is called a polynomial function. And here what these are: a naught, a1, a2, a3, an, that are any real numbers. Okay, that are any real numbers: a naught, a1, a2, a3 etc an, these are any real numbers. And power of x, x to the power n is there, no power of x, that should be a non-negative integer. Non-negative integer means that should be a whole number. Whole number means what? Either 0 or positive integers. Okay, so each power of x, if you see each power of x, here nothing is there means power of x is 0. Okay, next x means x power 1, 2, 3 like that. Power of x should be a non-negative integer means that should be a whole number. Power of x, each power of x should be a whole number, and these coefficients are what are real numbers: a naught, a1 etc an are real numbers. So function defined in this way are called polynomial functions. For example, I already wrote some functions in that which are polynomial functions and which are not polynomial functions. How to check whether a given function is a polynomial function or not a polynomial function? You have to observe a power of x. Each power of x must be a whole number. If any power of x is not a whole number, then that function is not a polynomial. Okay, so now first observe first one, f1 of x, and how that is x cube minus 5x square plus 8. Okay, just for an example I taken, and here you observe each power of x. Here power of x is 3, here power of x is 2, 3 and 2 they are whole numbers, that you know. So each power of x is a whole number, and coefficients a naught, a1, a2, a3 etc like that you have in the general definition. No, here what you have coefficients 1, no, here nothing is there means the number is 1, and here minus 5, 8 they are real numbers, always they are real numbers. And just you have to check whether each power of x is a whole number or not a whole number. If it is a whole number, if each power of x is a whole number, then that is a polynomial. If any power of x is not a whole number, then that is not a polynomial. Okay, here if you see each power of x, they are whole numbers, right? 3 and 2 they are whole numbers, so this is a polynomial function. And f2 of x, that is like this: x to the power minus 3 minus 5x square plus 8. Whether each power of x is a non-negative integer, whether it is a whole number, no, right? Minus 3 that is not a whole number, this is a negative number. Okay, so this is not a polynomial. Why? Because here power of x, that is minus 3, that is not a whole number. According to the definition of this, each power of x should be a whole number or a non-negative integer, but here you have negative integer. For that reason f2 of x, that is not a polynomial function. Next come to f3 of x, that is equal to x cube minus 5x to the power 2 by 3 plus 8. Whether this is a polynomial function, just you have to observe power of x. Each power of x you have to observe. Here power of x is a 3, that is a whole number. Here power of x is what? 2 by 3, that is not a whole number. Okay, 2 by 3, that is not a whole number. So for that reason this f3 of x that is not a polynomial function. Why? Because here you have power of x that is not a whole number. Okay, not a non-negative integer, it is not an integer, it is a fraction. Okay, it is rational number 2 by 3. So for that reason f3 of x is not a polynomial function. Next f4 of x cube minus root 5 x square plus 8. This is a polynomial function or not a polynomial function? You observe a power of x, each power of x. Here 3, that is a whole number. Here 2, that is also whole number. So each power of x is a whole number here. So this is a polynomial function. Okay. If I take one more, f5 of x that is equal to 1 by x cube minus root 5 x square plus 8. Whether this is a polynomial function or not a polynomial function, I'll rewrite that. Okay, f5 of x that is equal to, you have like this 1 by x to the power 3, that is in denominator, right? If you take that to numerator, how we write that? As x to the power is a positive in denominator. When you take to numerator, power will be negative. Okay, x to the power minus 3, and next you have minus root 5 x square plus 8. Here we rewritten that f5 of x, but in this if you observe power of x, what you can see, power of x here, first power of x that is minus 3, that is not a whole number, right? Minus 3, that is not a whole number. So for that reason f5 of x, this is not a polynomial. Okay, as it is, you can't see this as a not a polynomial, but if you rewrite that 1 by x cube as x to the power minus 3, then that power of x is not a whole number. So for that reason f5 of x is not a polynomial function. Okay, so in the notes you have to write this definition and these examples, and here if it is a polynomial, reason no need. If it is not a polynomial function, why? That reason you have to mention. Okay, it's not a polynomial function. f1 of x is a polynomial function. If they ask a reason, you just write because that follow the definition. Okay, and f2 of x that is not a polynomial function. Not a polynomial function because minus 3 is not a whole number or a non-negative integer. Okay, because power of x here, first power of x that is minus 3 is not a whole number. Okay, next f3 of x is not a polynomial function. Polynomial function because 2 by 3 power of x 2 by 3 is not a whole number. Okay, next f4 of x that is a polynomial function because here you can see each power of x is a non-negative integer. And last one, f5 of x that is not a polynomial function because power of x in this 1 by x cube is minus 3. Okay, power of x means this is actually 1 by x whole cube. If you write in x to the power something form, that will be x to the power minus 3. Okay, so there you will get a power of x negative, that is minus 3 is minus 3. Which is not a whole number. Okay, so suppose you have in any function like this 1 by x, 1 by x square, 1 by x cube, 1 by x, x to the power 5, 1 by x to the power 4, like these, then these are if you have like these are terms in any function, then that are not polynomial functions. But if you have like this 1 by x to the power minus 5, that is a polynomial function. Okay, if you write 1 by x to the power minus 5 in x to the power n form, that will be x to the power 5. So if you have only this one x to the power 5, that is a polynomial function. So just you have to observe that whether each power of x is a non-negative integer or not a non-negative integer. If it is if each power of x is a non-negative integer or a whole number, then that function is a polynomial function. Otherwise it is not a polynomial function. And we are not having the graph of a polynomial function for this general definition, but we have to draw the graph of polynomial functions f of x equal to x square and f of x equal to x cube. For these two polynomial functions, we have to draw the graph and also we have to write the domain and range for these two polynomial functions. Okay. You have under a polynomial functions x square and x cube graph and their domain and range. Okay, so now first one f of x equal to x square. So to draw the graph of f of x equal to x square, you have to find some points of that graph. Okay, so for that reason you draw table like this, x column and y column. Y is always f of x. Okay, f of x is what x square. So second number of that ordered pair you have to find by using this y is equal to x square. And actually you can take any real numbers in a x column, but for easy marking purpose in a graph I taken only integers. Okay, you can take any real numbers in x column. Here I taken only integers, some negative integers, some positive integers, with that 0. Okay, and for the minus 3, what will be the y value? Y is equal to x square minus 3 square. What is minus 3 square? Answer minus 3 into minus 3, that is plus 9. Okay, minus into minus plus 3 into 3, that is 9. Like that you have to calculate other y values for these x values. Now when x equal to minus 2 whole square, minus 2 into minus 2, that is plus 4. Next minus 1 square, that is what? Minus 1 square is plus 1. 0 square, square of this column you have to do, and that you have to write in the second column. Okay, 0 square is 0, 1 square is 1, 2 square is 4, and 3 square is 9. Okay, so these are points which you obtained in the table. You just mark in the graph, then you will get the shape of this graph of f of x equal to x square. Now first point you have to mark is minus 3 comma 9. Okay, at minus 3 you have to move up to what? Up to plus 9. 2, 4, 6, 8, 10. In between 8 and 10 you have what? You have 9. So here it is that. So this is the point minus 3 comma 9 and minus 2 comma 4. Second point you have to mark here minus 2 comma 4. At minus 2 you have to move up to 4. Okay, here it is. On y axis I take 1 centimeter as a 2 units. Okay, 2, 4, 6 like that, and on x axis I take 1 centimeter as a 1 unit. Actually negative side of a y axis no need, because here you are not having any negative values. Okay, only upper side of this y axis enough. And next for minus 1, what is the image of y answer? That is 1, minus 1 comma 1 point, that is here at minus 1 you have to move up to 1. Okay, exactly in between 0 and 2 you have what? You have 1. So this is the point. And 0 comma 0, 0 comma 0 means that is origin, here it is. Next point you have to mark is 1 comma 1. At 1 you have to move up to 1. Exactly in between 0 and 2 you have 1. Okay, here it is. And next point is 2 comma 4. At 2 you have to move up to 4. Here it is, that point. Next 3 comma 9. At 3 you have to move up to 9. Okay, exactly in between 8 and 10 you have a 9. Here it is. And if you take a 4 here, x place 4, then what you will get? You will get a 4 square 16. If you take a minus 4 also, you will get a same 16. Okay, so at minus 4 you have to move up to how much? You have to move up to 16. Here it is. And plus 4 also same, you have to move up to 16. Here it is. So here you got points of that graph, marked points of that graph. If you join that, then you will get the graph of that. Okay. So what is this? This is the graph of f of x equal to x square. So below the graph you have to write the name of the graph, that is name of the function f of x equal to x square. This graph is the graph of which function, that you have to write below the graph. Okay. Now you have to find the domain and the range of this function. What is the domain? Domain means you have to collect all possible values of x. You have to write all possible values of x, that gives you domain. And range means what are all possible values of y we can take, that gives you range of the function. Okay. To write a domain and range, you just observe the table, then you will get idea what will be the domain and what will be the range. Here I already said that you can take any real numbers in x column. So in x column what you have? You have all real numbers. Okay. So what is the domain? Domain is the set of all real numbers, means that is R. Okay. What is that? The set of real numbers. Real numbers. And what will be the range? See here, I will write here, if you take x 0, then y value you will get a 0, and if you take 1 you will get a y answer 1, if you take 2 you will get a 4, if you take a 3 you will get a 9, if you take a minus 1 also you will get a plus 1, for plus or minus 1 you will get y value 1, for plus or minus 2 you will get a plus 4, and for plus or minus 3 you will get y answer 9, plus or minus 4 16, plus or minus 5 25, like that. Okay. And observe these y values, how they are positive numbers or a 0. Okay. If you take a 0, then you will get a 0. If you take other than 0, then you will get what? You will get a positive answers, positive numbers, right? So y value, how y values are? Y values are either 0 or positive numbers. Okay. So in the y column what you have? Either 0 or positive numbers. We write that in the interval form as like this, 0 to infinity. Actually 0 to infinity means what? Here you have 0 and plus infinity. Just infinity means plus infinity. 0 to infinity means this much. Okay. This much is included, including 0. 0 and positive numbers. We write that in a symbolic form like this, in interval form like this, 0 to infinity. Or you can write this as a non-negative real numbers. All real numbers from 0 to infinity are there in a range. Okay. Here we showed only for integers. For integers you will get integer values, positive integers you will get. If you take a 0, you will get a 0. If you take a decimal number minus 1.5 like that, you will get like that positive number only. Okay. You will not get any negative numbers in the y column. So range of this function y is equal to f x equal to x square, that is what? That is non-negative real numbers. Okay, this is important. Thank you. Second function in a polynomial function is f of x equal to x cube. Okay, for that you have to draw the graph and you have to write the domain and the range of that. Okay, f of x equal to x cube. For that I taken some integers, negative integers, positive integers and 0. Okay, you can take any real numbers in the x column. Okay, for any real number x you can find a x cube answer. So for that reason you can take any real numbers here. Okay, in x column you can take any real numbers. And what will be the y value? Y is equal to x cube. Cube of x you have to write in the second column. Okay, now minus 3. Minus 3 cube is what? That is minus 27. Okay. Next minus 2 whole cube. Minus 2 whole cube means minus 2 into minus 2 into minus 2, that is minus 8. Then minus 1 answer is minus 1 whole cube is what? That is minus 1. Then 0 cube, that is 0. Then 1 cube, cube of 1 is 1. Cube of 2 is 8. Cube of 3 is 27. If you take a 4, then cube of 4 is what? 64. And what is cube of minus 4? Cube of minus 4 is minus 64. We mark all these points in a graph. Okay, always to draw the graph you have to draw x axis and y axis. And now I'll take on x axis 1, 2, 3, 4 etc. like that. 1 centimeter as 1 unit because here we taken integers. For easy marking system I taken only integers. You can take any real numbers here actually. Okay. So on x axis we take 1 centimeter as 1 unit and here you observe y values minus 64, minus 27, plus 64, plus 27 like that. Larger numbers are there. For that reason I taken 1 centimeter as 10 units. Okay, 10, 20, 30, 40 like that. You mark on both axis, on negative axis also, on negative side of y axis also take 1 centimeter as 10 units. So now mark these points which you obtained in the table. First point is minus 4 minus 64. At minus 4 you have to move up to minus 64. You have to move down till you reach minus 64. Okay, minus 60 and minus 70. In between that you have okay, that somewhere here minus 64, it is here somewhere here. This is not exact figure in what in your scale. Suppose here you have minus 60 and here you have minus 70. Then after minus 60 fourth line is there, no, that will be minus 64. Okay, here you have total 9 lines in between minus 60 and minus 70. You have 9 lines. In that after minus 60 fourth line will be for minus 64. Okay, like that you can mark, but here it is not that much easy to mark minus 64. Okay, and next point you have to mark is minus 3 minus 27. At minus 3 you have to move up to minus 27. In between minus 20 and minus 30 you have minus 27. After minus 20 horizontal line, 7th line is there, no, that is for minus 27. So somewhere here you will get. Okay, so this is a point of minus 3 minus 27. Next minus 2 minus 8. Minus 2 8, that is after this x axis, below the x axis, which line? 8th line, that is the 8th horizontal line, that is for minus 8. So here it is that point. Next minus 1 minus 1. Okay, below the x-axis first line is for a -1, somewhere here you will get okay. So this is for a -1 comma -1, and next point is 0 comma 0, okay. It is here, and I will draw this, okay. Join that. So like this you will get on the negative side of y-axis. Next we go to positive side of x-axis, okay. 1 comma 1, first point 1 comma 1, above the x-axis first line is for a 1, okay. So this is a 1 comma 1. Next 2 comma 8 you have above the x-axis 8th line is for a what 8. So this is a point 2 comma 8, this point. Next 3 comma 27, at 3 you have to move up to 27. After 20th horizontal line, 7th line somewhere here you will get, okay. That is for what? That is for 27, 3 comma 27. Next 4 comma 64, 60 is here, right, and after 60th horizontal line, 4th line is for somewhere here you will get is for 64, okay. So like this you will get on positive side of x-axis. So you join these points. So then you will get a shape, So this is for which function? This is for y is equal to x cube, or f of x equal to x cube. Below the graph you have to write without missing the name of the graph or a function, f of x equal to x cube. Now we have to write the domain and range, okay. What will be the domain and range? See here, I said already in x column you can take any real numbers in x column. So domain is what? The collection of all x values, collection of all possible x values, that is nothing but the set of real numbers, okay, are the set of real numbers. And range, if you observe these y values, what you can see here, 0 is there, negative numbers are there, positive numbers are there, okay. Here we taken only integers, for that got only integer answers here, but I said already that you can take any x values here, any real numbers as x values. For that you will get like that, if you take a negative real numbers you will get a negative real numbers in a y column. If you take positive numbers you will get a positive real numbers in a y column. If you take a 0 you will get a 0. So all negative real numbers will be there in y column, and all positive real numbers will be there in a y column, and 0 also there, okay. So you have what? Negative real numbers, positive real numbers, and 0 also. So all real numbers are there in a y column, but here you can see only some integers, okay. So what is the range? Range is also the set of real numbers, because here you have negative numbers, positive numbers, and 0. All real numbers you have in this y column, okay. All negative real numbers are there, all positive real numbers are there, and 0 also there. So range is also what? R. And what is R? R is the set of real numbers. So this is about a polynomial function, okay. Next function is a greatest integer function. That function is defined in this way. A function f from R to R defined by f of x, that is equal to x, okay, x. If x belongs to z, means if x is integer, that only will be the y value, okay. Always we take f of x as a y value, okay. So y is equal to what? Y is equal to x only if x is a integer. X belongs to z means integer. For example, suppose you have f of 1, 1 is integer, okay. This is x now. What we write inside this bracket, that is x value. F of 1, that is equal to 1. If you take integers 1, 2, 3 like that, then what is f of 2? That only will be the y value, means the f answer. If you take a f of 3, if you take a 3 is an integer, so what is the f answer? That is 3 only. If you take 4, then what is f of 4? That element only, okay. F of x that is equal to x only. F of x equal to x, f of x equal to x. If you take integers 1, 2, 3, 4 etc. or minus 1. If you take f of minus 1, then what is answer? Minus 1. If you take minus 2, then f of minus 2 is a minus 2. If you take f of minus 3, then answer is minus 3. Okay. If you take minus 4, then what is y answer? Y answer is minus 4. Okay. This is the place for x, and what answer you are getting, that will be the y value. Okay. Y answer or f of x value. Okay. So like that you have to keep in mind. And if it is not an integer, if you take a real number which is not a integer, then now what will be the y value, that is f of x answer. F of x you have to take like this: greatest integer less than x, greatest among the integers which are less than x. How to find the value of here? It is little bit complicated. It looks complicated, but if you understand, that will be very easy. Okay. F of x equal to greatest integer less than x if x does not belongs to z. If x does not belongs to z means if x is not a integer, then to find y value you have to use a second line, that is the greatest integer less than x. You have to see which are the integers which are less than x. How many integers you have less than x? You have infinitely many integers which are less than x, but among that integers you have to consider the greatest one. Okay. For example, if I take a 2.1, okay, 2.1, that is not integer. So then what will be f of 2.1? This is not integer. Okay, 2.1 is not integer. So which definition you have to use? Second line definition you have to use. Greatest integer less than 2.1. Okay, greatest integer less than what is x now? X is 2.1. Okay, less than 2.1 now you have many integers, right? Where is 2.1? After 2 you have 2.1 somewhere here, right? 2.1 less than 2.1. How many integers you have? You have many integers, but in that integers you have to consider what? You have to consider the greatest one, greatest integer which is less than 2.1. You have you have 2, 1, 0, minus 2, minus 3, minus 4, minus 5, etc. Like that you have many integers which are less than 2.1, but in that which is the greatest one? That is 2. Okay, which are the integers less than 2.1? 2, that is less than 2.1, then 1, 0, then minus 1, minus 2, minus 3, minus 4, minus 5, like that you have many integers. Okay, these are integers which are less than 2.1, but in these integers which is the greatest one? Greatest one is 2, right? So like that you have to find the y value or f answer. So here to draw the graph of a greatest integer function, I take some x values, okay, so that we can draw the graph of a greatest integer function easily. Okay, here it is by doing like that table means previous which we taken table like x value minus 3, minus 2, minus 1. If you do like that you won't get a exact picture of this greatest integer function. So for that reason I take integers in top row and some real numbers below that. Okay, and first f of minus 3, f of minus 3 comes in which category? That comes in a first line, right? F of minus 3, that is a what? That is an integer. If it is an integer, if x is an integer, that only y answer. Okay, so here f of minus 3 is what? That is minus 3. What is f of minus 2? minus 2 is an integer, so f of minus 2 is a that only, okay, and f of minus 1 is what, that is minus 1 only, f of 0 is what, that is 0, f of 1 is what, that is 1, f of 2 is what, that is 2, f of 3 is what, that is 3, because all these are what, integers. X belongs to z, then y is equal to, or f of x is equal to x only. What you taken here, that only you have to write. So in a first line I taken only integers, minus 3, minus 2, minus 1, 0, 1, 2, 3, they are all integers. So their f answers will be that only, minus 3 for minus 3, minus 3 for minus 2, minus 2 for minus 1, minus 1 for 0, 0 for 1, 1 for 2, 2 for 3, 3, like that, or you can take a next also, okay. But this much enough to draw the graph. And next come to these real numbers, minus 2.9. What is f of minus 2.9? Minus 2.9, that is not integer, right? Where that minus 2.9 lies in number line, you know that that lies somewhere here, minus 2.9, right? Minus 2.9, you have to see like this, which integers are less than minus 2.9, that in that integers which is the greatest one, that you have to write here, okay. Minus 2.9, less than that you have many integers, you have infinitely many integers which are less than minus 2.9. Which are integers less than minus 2.9? Minus 3, minus 4, minus 5, minus 6, like that you have infinitely many. But in these integers which are less than minus 2.9, which is the greatest one? Greatest one is minus 3, right? So what is the answer for this? Answer is minus 3. Like that for these also you have to see minus 2.5. Where is minus 2.5? That is exactly middle of minus 2 and minus 3 on the number line, right? So here you have minus 2.5 and less than minus 2.5. Which integers comes minus 2.5? Less than that you have minus 3, minus 4, minus 5. Again same. Okay, minus 5, minus 6, etc. Many integers you have, infinitely many integers you have, but in that which is the greatest one? That is minus 3. Okay, so here also you have answer minus 3. And f of minus 2.1. What is answer for that? When is minus 2.1? Here it is. Okay, somewhere here in between minus 3 and minus 2 you have minus 2.1. Okay, here you have minus 2.1. And less than that which integers are there? Minus 3, minus 4, minus 5. Okay, you have to consider integers which are less than this. Okay, minus 3, minus 4, minus 5, minus 6, minus 7, etc. Many integers you have less than that. But in that you have to consider the greatest one. What is the greatest one among that integers? That is minus 3. So here also answer is minus 3. Minus 2.01, that lies very close to minus 2, but okay, very close to minus 2, but on this side, okay, left side of minus 2, very close to minus 2 you have minus 2.01. okay, minus 2.01. For that which integers you have less than that? Less than that you have minus 3, minus 4, minus 5, etc. Again same integers you have, but in that what is the greatest one? Greatest one is again minus 3. Okay, so answer for this is also minus 3. So like that can you write the values for these all which I left blank? See here what you can see in this column you have all f answer, that is minus 3. So what you can say from these values by observing these values? See, for minus 3 it is a minus 3, and for minus 2.01 it is a minus 3. If you take see, I'll highlight that here you have minus 3, here you have minus 2. If you take any real numbers from minus 3 to minus 2, what will be the f answer for that? See here, first I taken f of minus 3, next minus 2.9 somewhere here, minus 2.5 somewhere here, minus 2.1 somewhere here, okay, minus 2.01 somewhere here. So if you take any real numbers which are between minus 3 to minus 2, but except minus 2, delete this minus 2. from minus 3 to minus 2, if you take any real numbers, what will be the F answer? You can see here F answer is minus 3, because for that real numbers, greatest integer which are less than that real numbers is always minus 3 only. Okay, if you take any real numbers, in general I will take x, if you take any x which is in this interval means a half closed interval minus 3 to minus 2, except minus 2, why? Because for minus 2 answer is minus 2. If you take any real number from minus 3 to minus 2, half closed interval closed on minus 3 side, then what will be the F answer? F of x is equal to what? That is equal to minus 3. Okay, here I shown only some real numbers which are between minus 3 to minus 2. Okay, so you can take any minus 2.8, for that also minus 3, minus 2.7, minus 2.6, minus 2.4, minus 2.3, minus 2.0001. For all that F answer is what? That is minus 3. Okay, so in short we can write this like this also. Instead of writing like this, we can write like this also. If x belongs to half closed interval minus 3 to minus 2, then minus 2 side open bracket means minus 2 is not there in this interval. Okay, what is the F answer? F of x answer will be minus 3. You can write in this way also. Okay, instead of writing this much, you can write like this also, or otherwise you can write F of x equal to is equal to minus 3 if x belongs to half closed interval minus 3 to minus 2. Like this also you can write. Okay, in textbook they given like this, but if I write like this, you can't understand why like this, why answer F answer is minus 3. So for that reason I written in detailed way. You write in notes in this way only. Okay, detailed way, and short way you have in the textbook. If you want short notes, then you can refer that textbook. Now we come to second column, this column now. F of minus 2 we already wrote, then F of minus 1.9, where it comes F of minus 1.9, that comes somewhere here, right, very close to minus 2, but on the right side of minus 2. If you have a real number here minus 1.9, then which integers are less than minus 1.9? You have minus 2, minus 3, minus 4, minus 5, minus 6, etc. You have infinitely many integers, but in that what is the greatest one? Greatest one is minus 2. So answer here is what? That is minus 2. If you take a minus 1.5, where is minus 1.5? That comes somewhere, sorry, here actually after minus 2 you have 1, minus 1, then 0, then 1, 2, 3, 4, like that. Okay, so where is minus 1.5? Minus 1.5, that is somewhere here, exactly in between minus 1 and minus 2. You have what? This is minus 2, minus 1, exactly in between minus 1 and minus 2. You have minus 1.5. Okay, so if you see integers which are less than minus 1.5, which integers you have? Minus 2, minus 3, minus 4, minus 5, etc. In that what is the greatest one? Greatest one is minus 2. So answer for this is also minus 2. If we take minus 1.1, that comes here, right? Minus 1.1, that comes here, and if you see integers which are less than minus 1.1, you have minus 2, minus 3, minus 4, minus 5, again same integers. In that greatest one again it is minus 2. If you take minus 1.01, that comes somewhere here, minus 1.01, okay, here, and integers which are less than minus 1.01 are minus 2, minus 3, minus 4, minus 5, etc. In that what is the greatest one? Greatest one is minus 2. So answer is what? Minus 2 here. If we take see what we taken, now we taken numbers in between minus 2 and minus 1. Okay, we not taken minus 1. From minus 2 to minus 1 we taken except minus 1, except minus 1, to indicate that you have to use a open bracket. Okay, closed bracket means minus 2 is there in that, minus 2 is there and minus 1 is not there in this column. So what we taken now, we taken numbers from minus 2 to minus 1 except minus 1. For all that, what is the F answer? F answer is minus 2. That you have to keep in mind. Okay, that will help to draw the graph next. And next you have what? Next, f of minus 1 that we wrote already, that is minus 1. Where is the minus 0.9? That comes somewhere here. Okay, minus 0.9. And if you take that minus 0.9, then integers which are less than minus 1.9 are minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, etc. In these integers, which is the greatest one? Greatest one is minus 1. So answer for this is what? Minus 1. For minus 0.5, minus 0.5 comes here exactly in between minus 1 and 0. You have minus 0.5. If you take integers which are less than minus 0.5, you have minus 1, minus 2, minus 3, minus 4, etc. In that, what is the greatest one? Greatest one is minus 1. Okay, we have many integers which are less than this, but in that you have to consider the greatest one. Greatest one that you have to enter here. Okay, if you take a minus 0.1 that comes here, right, and for that which are the integers less than that? Minus 1, minus 2, minus 3, minus 4, etc. Again, greatest one among that is minus 1. Okay, minus 0.01 that also lies in this interval only. Okay, minus 0.01 that comes here. Okay, left side of 0, but to the right side of minus 1 that comes here, minus 0.01. If you see integers which are less than minus 0.01, you have many integers, minus 1, minus 2, minus 3, minus 5, etc. Many integers you have. In that the greatest one again it is minus 1. So if you take any integers from minus 1 to 0, but except 0, we not taken 0 in this column, except 0. Okay, for all that real numbers, what is the greatest integer less than that? That is always minus 1. Okay, so that we wrote in this column. Next, f of 0 that we already wrote, that is what? 0. Next, f of 0.1. You have number line like this: 0, 1, 2, 3, next minus 1, minus 2, etc. like that. F of 0.1, where it comes? That comes here, right? F of 0.1, and you have to see now integers which are less than 0.1. You have many integers: 0, minus 1, minus 2, etc. Many integers you have: 0, minus 1, minus 2, etc. In that, what is the greatest one? Greatest one is 0. So here answer is what? 0. For 0.1 that comes here, somewhere here. Okay, so if you see integers which are less than 0.1, then you have 0, minus 1, minus 2, etc. In that greatest one is 0. So like that, if you take 0.5, again you have same integers which are less than that. Okay, 0, minus 1, minus 2. In that greatest one is what? 0. And for 0.9 comes here. Okay, integers which are less than that, again you have seen 0, minus 1, minus 2, etc. In that greatest one is 0. Okay, so like this you have to see. Next, f of 1, that is 1. F of 1.01, where it comes? See, f of 1 we already wrote, that is 1. Next, f of 1.01 that comes somewhere here, and less than that, which integers you have? 1, 0, minus 1, minus 2. Okay, in this column what you have? You have integers 1, 0, minus 1, minus 2, etc. Like that you have. These are the integers. These are the integers which are less than these numbers, right? In that, what is the greatest one? Greatest one is 1. If you take any real numbers from 1 to 2, but except 2, then for all that real numbers, integers which are less than that real numbers are 1, 0, minus 1, minus 2, etc. like that. Okay. But in that, what is the greatest one? Greatest one is 1. So answer for all these is what? That is 1, 1, 1. Okay. I will not explain in detail now. Next come to this column. F of 2 we already wrote, that is 2. Next f of 2.01. Here you have 0, 1, 2, 3. Next left side minus 1, minus 2, like that. F of 2.01, that comes somewhere after 2, here, somewhere here. Okay, 2.1. And if you see integers which are less than 2.1, you have many integers actually, 2, 1, 0, minus 1, minus 2, etc. Like that you have many integers, but in that what is the greatest one? Greatest one is 2. So answer for this is 2. And if you take a 2.1 also, here we taken 2.01. Next, if you take a 2.1 also, you have same integers which are less than that. Okay, same integers means 2, 1, 0, minus 1, minus 2, etc. In that, what is the greatest? Again 2. If you take a 2.5, here it is 2.5, exactly between 2 and 3. If you see integers which are less than 2.5, again you have same integers 2, 1, 0, minus 1, minus 2, etc. In that, what is the greatest one? Greatest one is 2. So answer is 2 for all these real numbers. Okay. And next to f of 3. F of 3, that we wrote already. What is f of 3.01? Where it comes 3.01, that comes somewhere here. Okay, 3.01. 3.01. For that, which integers are less than that? 3.01. For that for that integers which are less than that are 3, 2, 1, 0, minus 1, minus 2, minus 3, etc. Okay, you have to see the integers which are less than that real number which you taken, and after that you have to see which is the greatest one. Greatest one is 3. So answer is what? Here 3 for this. If you take a 3.1 also, 3.1 comes somewhere here, 3.1. Then also what you have? Same integers you have which are less than 3.1. So greatest one among that is again 3. And if you take a 3.5, here it comes 3.5. If you see integers which are less than 3.5, again you have same 3, 2, 1, 0, minus 1, minus 2, etc. So again greatest one is what? 3 only. If you take a 3.9, that comes here, 3.9, lesser than that you have many integers 3, 2, 1, etc. like that. But in that what is the greatest one? Greatest one is plus 3. Okay, so answer is plus 3. So what we can see this is the 3 and this is 4. If you take any real numbers from 3 to 4, but not 4, what is the image of a 4? Here I not wrote f of 4, answer will be 4. Why? Because this is the integer. If it is an integer, that only what f answer. If you take any real numbers from 3 to 4, then what will be the f answer? F answer is what? That is 3. If you take any real numbers from minus 3 to 4, but except 4, what is the f answer? F of x is equal to 3 for all x in this half closed interval 3 to 4, half closed interval 3 to 4. So with these information, we draw the graph. To draw the graph, you have to draw x-axis and y-axis. On x-axis and y-axis, you mark points at equal distances. Okay. So now first we mark that f of minus 3. What is f of minus 3? F of minus 3 is see the first column, okay. F of minus 3, that is the minus 3. Here you have minus 3. At minus 3 you have to move up to minus 3. Here it is. For minus 3, answer is minus 3, and for minus 2.9, okay, here to the right side of minus 3, somewhere here. For that also answer is what? Minus 3, and for minus 2.5, for minus 2.5 also answer is minus 3, and for minus 2.1 answer is minus 3, and for minus 2.01, for that also minus 3, okay. So join these all points, so then we will get like this, okay, like this line. But if you draw like this, that indicates image of minus 2 is also minus 2. But what you know, image of minus 2 is whether it is minus 3, it is not minus 3, it is minus 2, right. But if you draw like this line, that indicates image of image means f answer is minus 2, but it is not minus 2, right. So to indicate that, you have to draw small open circle at minus 2 like this, okay. What is image of minus 2? Image of minus 2 is minus 2, right, that is here. So here you have to draw a closed circle. Closed circle means like this, okay. If you draw circle and if you shade that, that is a closed circle, that indicates image of this 2 is 2. And if you draw open circle means if you draw just a circle without shading, then that is called open circle, okay. Open circle indicates that open circle at minus 2 indicates that image of minus 2 is not this one, minus 3, okay. Like that you have to keep in mind. And next f of minus 2, that we marked, that is minus 2. What is next? In a second column you see f of minus 1.9, that comes somewhere here. Image of that, image means f answer is minus 2 again, and image of minus 1.5, that is also minus 2, and image of minus 1.1, that is also minus 2, image of minus 1.01, that is also minus 2. So graph comes like this, from minus 2 to minus 1, graph comes like this, means image of that is minus 2, but image of minus 1 is not minus 2, right. To indicate that, you have to draw small open circle at minus 1, okay. Then what will be the image of minus 1? We wrote already, image of minus 1 is what? Image of minus 1 is minus 1, okay. You have to draw closed circle at minus 1. Image of minus 1 is what? That is minus 1. Next, you see that third column, f of minus 0.9 comes somewhere here. Image of that is what? That is also minus 1. Image of minus 0.5, that is also minus 1. Image of minus 0.1, that is also minus 1. Image of minus 0.01, that is also minus 1, okay. So if you take any real numbers from minus 1 to 0, but except 0, what is the f answer? Image is minus 1, and you join that all points like this. But if you draw like this, that indicates that image of 0 is also minus 1. But we know that what is the image of 0? It is not minus 1, it is 0, okay. So to indicate that, you have to draw small open circle at 0 like this, okay. So that indicates what? Open circle at 0 indicates that image of 0, that is not minus 1, image of 0 is what? That is 0, okay. So 0, 0, and what is the image of 0.01? That is also 0, that is here. And image of 0.1, image of 0.1, that is also 0, image of 0.5, that is also 0, image of 0.9, that is also 0. If you take any real numbers from 0 to 1, then image of that is what? Image of that is 0. But image of 1 is what? Image of 1 is not 0. To indicate that, you have to draw small open circle at 1. Okay, what is the image of 1? Image of 1 is 1. We already wrote that. Okay, so image of 1 is 1, image of 1.01 is also 1, image of 1.5 is also 1, image of 1.9 is also 1, but image of 2 is not 1. To indicate that, you have to draw open circle. Now you join these points. Okay, so graph comes like this from 1 to 2 except 2. Okay, and what is the image of 2? Image of 2 is 2. Okay, image means these are called images. F answers, we say that as image. F of 2 is 2, image of 2 is 2, and image of 2.01 is also 2, and image of 2.5 that is also 2, image of 2.9 that is also 2. Okay, so you have like this graph from 2 to 3, but not at 3. At 3, what is the image? Image of 3 is not 2, image of 3 is what? Image of 3 is 3, that is here. Okay, so to indicate that image of 3 is not 2, you have to draw open circle at this point, and image of 3 is 3. To indicate that, you have to draw closed circle at 3, 3. Okay. Next, f of 3.01 is also 3, f of 3.1 that is also 3, f of 3.5 that is also 3, f of 3.9 that is also 3. If you take any real numbers from 3 to 4, then what is the image? Image is what? 3. Okay, so you have graph like this, but image of 4 is not 3. Okay, to indicate that, you have to draw open circle at 4. Okay, so like this you have a graph for a greatest integer function, and for greatest integer function we have a symbol. Okay, this is a symbol for a greatest integer function. F of x is equal to greatest integer function. If you write x inside that square bracket, that symbol is for a greatest integer function. Okay, here also you can write a greatest integer function, and a symbol for that is like this. Inside a square bracket you want to write x. So here what you can see, you have a graph like a step like a structure. Okay, step to step you have. So this function is also called a step function, but we are not using that much. So step function means what you have to understand, that is nothing but greatest integer function. Okay, so now this is about the graph of a greatest integer function. Now we have to write the domain and range of these greatest integer function. What will be the domain? See, you can take any real numbers, right? We taken integers and we taken real numbers also. So what are all possible values of x? See, if you write in this way, this is the place for x. Okay, all possible values of x, that will be the domain, and what is the f answer? That will be the y value. Okay, all possible values of y or all possible values of f, that gives you range. Okay, now what we taken in place of x? We taken real numbers, right? We taken integers in first line, and next lines we taken what real numbers, minus 2.9, minus 2.5, like that. So in x place you can take any real numbers. So what are all possible values of x? That are real numbers. Okay, all real numbers we can take in place of x. So if you collect the set of all possible values of x, what you will get? You will get the set of real numbers, that is R. Okay, so domain is what? Domain is R. Domain is equal to R. And what is the range? What is the range? Range means you have to collect all possible values of y. Y means f answers. You see f answers minus 3 here, you have minus 2 here, and you have minus 1 here, f answers. You have 0 here, here you have 1, and here you have 2, here you have 3. Okay, you have only integer answers. minus 3, and if you continue left side you will get minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. These are the F answers. Okay. So what these are? These are integers, right? So if you take any real numbers in x place, F answer you will get integers only, either minus 3 or minus 2 or minus 1 or minus 4, minus 5, minus 6, etc. left side, or 0 positive side, 1, 2, 3, etc. like that you will get. So if you collect all possible values of F answers, that is all possible values of y, then you will get all integers, that is the set of real numbers. So what will be the range? Range is z. Z is means z is what? The set of real numbers. And what is R? R is the set of real numbers. Sorry, here what is that? Z is the set of integers, okay, not real numbers. Correct it. Range is z, that is the set of integers, minus 3, minus 2, minus 1, 0, 1, 2, etc. Okay, and collection of all possible values of x, that is R, that is the set of real numbers. Okay, thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.